Hello, everyone. My name is Jacqueline Garcia, and my group members are Ellen Hambley and Hector Villalobos. And for our project, we created the Simon Says box. These are a few things pertaining to our project that we will be going over in this presentation. So, our Simon Says box was inspired by the game Simon, which, if you don't know what that is, it's a game where random patterns of colors are displayed, and the goal of the game is to match the sequences in the correct order. However, we also wanted to add the features of the useless box in order to make it more interactive. The useless box is a box that uses a servo arm in order to flip a switch in the opposite direction, and the user switches it, and that is pretty much its whole purpose. The flipping of the switch goes back and forth between the user and the servo arm, and because it's the only thing it does, it's called a useless box. By combining these two different ideas and adding our own touches, we came up and designed the Simon Says box, as you can see in this slide. So for our design, we used two servo motor arms, which are designated in orange, and we utilized the arm that would originally flip the switch in the useless box instead to hold up a sign and appear during our losing sequence instead of flipping the switch. Our second arm, which is called the lid arm in our figure, is used to open the lid in order for the sign arm to be able to come out, display the sign, and hide back inside. In order to start and end the game, we implemented an on and off toggle switch, which is used at the player's discretion. Our LEDs are where the sequences will appear to the player, and they can match it by pressing the corresponding arcade buttons. In addition to that, after each sequence is correctly played by the player, we incorporate an LCD screen in order to keep track of what level the player is on. And it's also programmed to display a message such as "you lose" whenever the player incorrectly presses a button. And some things that we customized to our own liking included the LCD screen messages as well as the 3D printed sign, which you will see in our video later.
Greetings, my name's Alan. Here is the one-line diagram. The arrows in red represent the power supply to our necessary components. The blue arrows represent our information flow, whether it be input or output data. We will begin at the power supply. The power first enters the on-off switch, followed by the Arduino and the servo motors. We were not able to run the motors off of the power given from the Arduino as it drew too much current through the Arduino. Therefore, we have given the servos its own power supply. Briefly, the Arduino sends a random sequence to the LEDs. The user repeats the sequence using the buttons. If the repeated sequence is correct, the LEDs will flash once and the next part of the sequence will be given. The score will be updated in the LCD display. If you repeat an incorrect sequence, then the LEDs will flash 3 times, the LCD display will indicate that you lost, and the servo motors will initiate, opening the lid and showing the "you lost" sign. This is a digital representation of our game. Beginning at the top left diagram, we see that the Arduino has given the first part of the pattern. The player, indicated by the arrow in the middle of the diagram, matches the sequence by hitting the yellow button, which illuminates the yellow LED. Since it is a correct sequence, the LEDs will blink once and the LCD will update the score. On the second row, we see that the player has a score of 8. The game has now given a pattern of 9. The user, indicated by the blue arrow on the second diagram, has hit the red button and, unfortunately, fails the sequence, as the last blip in the sequence was blue in the first diagram. Since this is a failed sequence, all of the LEDs will blink 3 times and the servo motors will spin into action, beginning the losing state. The first servo lifts the lid open, revealing the interior of the box, which is indicated by the dark green area, and the second servo shows a little sign which may say "you lose." The LCD will update and reset the score to begin the game once again. This is the overall statement sheet diagram. This is to provide a better understanding of what is going on in the mind of the Arduino. Here, we turn the game on and the LCD will provide the intro to the game, greeting the player and preparing the first random sequence. I say first because the user will probably not stop playing this game for a while. The LCD will show a score of 0 and the games will begin. If there's an incorrect sequence, or if you happen to have the memory of an elephant and get to a score of 100, the losing state will be initiated as explained previously. The next slide will provide a more detailed explanation between the gameplay state and the losing state.
Here we have the 2 different states. For the game, we see the blink called N, which is the amount of times the LED pattern occurs. If you press the button and it's the right button, it goes to the true statement, in which n adds one more to the repeated sequence. If the wrong button is pressed or you pass level 100, it goes to the else statement, in which it triggers the losing sequence and shows a losing message on the LCD, and does the arm movements, in which it goes back to the game state when finished.
We 3D printed the majority of the body, in which we have the 4 buttons settled at the bottom of the base, and then we have 4 ping pong balls for each of the LEDs. We 3D printed the bottom of the box, the faceplate, the flap, and the hinge. And inside we have 2 servo holders, which hold our servos in place, and they're both placed in these positions. The battery pack is in the on position. To connect the circuit, just flip the switch and it lights up. As soon as you start the game, the LCD will show you a little introduction, a little greeting, and then it will tell you to get ready for the game before it starts lighting up. You will start off with a basic score of 0, and every time you push a button corresponding to the light, the score will increase and then move on to the next level. But as soon as you press the wrong button, you'll lose. As soon as you mess up the sequence, the losing sequence will commence, in which one servo opens the lid, then the servo shows you a message, and then it closes, after retrieving the arm with the message. Let me show you a proper gameplay of the game. So here we can see the LEDs lighting up and me just following the code. The game just cycles through, always adding one more blink to the previous pattern. The game is able to reach up to a score of 100, but wherever you do not mess up the pattern or else. So that's the basic gameplay of our Simon box. But for the best way you can enjoy the game, you can play the game at night or in a dark room. And once you reach a high enough level, this is how it's gonna look.
Here are just a couple of pictures from the project process, in which you can see all the troubles that my group went through trying to build this project, from failed prints and just a whole bunch of wires being tangled up. So next slide, please. So in conclusion, my advice to you guys is to print parts early. It can be test prints provided online, just so you can get a feel for 3D printing, and just print your parts better.
My recommendation is always double check your grounds. We missed a couple of jumpers early on when we were initially assembling it. We later found that we just missed those 2 jumpers after doing a double check. So it set this back a little bit in time, but after finding the issue, we were able to come back quickly and resolve our problems.
My advice would be to just be consistent and communicate well with your team. I noticed that we just meeting with our teams every single week for at least 4 hours a week was helped us a lot in the long run, and it just lightened up the workload in the end. So yeah. Lastly, we'd like to thank the CMA ET department, our professor Chang Su, for teaching us how to code from scratch and just being there anytime we needed him. We'd like to thank Aaron Cole, Jack Whalen, Gage Sturgeon, who was our tutor and also met with us whenever we needed help, and Group 3 for lending us their servo motors as well. That is the end of our presentation. Thank you.